Whenever we look at congruent polygons, or in this case triangles, we have to remember the definition. And two polygons are congruent if and only if they're the exact same size and shape. Or we could say their corresponding parts are congruent. So this foundational definition is where it's going to carry us through this unit. But what does it really start with? So we have two triangles here. I have ABC and DEF. I'm going to say that the two triangles are congruent. So triangle symbol, name the triangle, congruent symbol, and then the other name. That means all of their corresponding parts are also congruent. And what we mean by corresponding parts would be the sides and the angles. So I have AB and DE are corresponding sides, BC, EF, and AC, DF. All three of those sets are congruent to each other because the triangles are congruent. When it comes to angles, I have angle A is congruent to angle D, B is congruent to E, and C is congruent to F. Now, I've labeled them all. Same markings means they're congruent throughout the triangles, and then we can go through and name all the parts. So what does that statement mean? So I have triangle WYS is congruent to triangle MKV. This is what we call a congruent statement. So that tells us two triangles are congruent. I don't know what those triangles look like, but I know they are congruent to each other. They are the exact same size and shape, and all of their corresponding parts are congruent. So let's see. If I knew angles, I know the angles in the first one, WYS. I have angle W, angle Y, and angle S. Each of those is congruent to another angle in the other triangle. So W, because it's the first letter by its name, is congruent to angle M. Angle Y, being the second letter, is congruent to angle K, and angle S is congruent to angle V. Remember that order that we have up here is very important because it tells us the order that the parts we can match. Same thing applies to the sides. WY is the first two letters. I can match that to MK. WS is the first and third letter. That's going to match to MV. And then our third congruence, YS, is congruent to KV. Three sets of sides, three sets of angles. Now we're given our two triangles are congruent, and we have some values down here. So now we're going to go from the idea that corresponding parts are congruent to their measures being equal. So congruence deals with parts, angles, and sides and matching them up. There's no numerical measurement going with it. We're not looking at sides and saying there's so many units in length, and we're not looking at angles saying what their measures are in degrees. What we're looking at is saying those objects are exactly the same. When we go to this idea of measures being equal, we take the measurement of sides and measurements of angles and saying, well, if they're corresponding and congruent, then they're going to have the same measurement. We can also see the difference here with something as segment BN. No longer a segment line on the top and no longer congruent symbol. When we see just in the two letters and an equal, it's going to be equal to a numerical value, something we can measure. So BN, we know, is corresponding, its first and third letter, to SW. SW is 9, so I'm going to say BN is equal to SW, which is equal to 9. TW is the second and third letter, so that's congruent to FN, so that would be congruent to 14. Then last we have BF. BF is congruent to ST. ST is 17, so BF is 17. Now our angles. Angle W, looking at the names, is the third letter, so that's angle N. So W is corresponding to N, so that is 82 degrees. Angle B is the first letter of the triangle, so that's corresponding to the first letter here of S, so that would be 67 degrees. And we could even go back to these two triangles and write in these new measurements that we found. Now lastly here I have to find the measure of angle F. Now angle F is corresponding to angle T. I don't know that measurement, but because it's a triangle and the angles add up to 180, we can add 82 and 67 and get 149. Subtract 149 from 180 and we get 31 degrees, not only for angle F, but would also be angle T. So we can use the fact that the angles add up to 180 to sometimes help us with that. So as we go through these practice ones, it's important that we understand that we're labeling things correctly, we're naming things correctly, and we're going through matching up corresponding parts. So I have in triangle JKL and PQR. I'm going to name my side congruences first. JK is congruent to PQ. The next two sides, I'm going to go KL is congruent to QR. My last one, I'm going to go LJ is congruent to RP. Now, maybe you went JL, that's fine. JL would be PR. Just pay attention to the order as you go. Then angles J, angles K, and angles L are from the first triangle. And so J matches to angle P, angle K matches to angle Q, and angle L matches to angle R. Next problem, same thing. Sides, WX, XY, and WY. WX is corresponding to EF. XY is corresponding to FG. And WY is corresponding to EG. For angles, I have angle W, angle X, and angle Y. Angle W matches to angle E. Angle X matches to angle F. And angle Y matches to angle G. Next, I need to name three congruent triangle pairs, or three congruence statements. So let's see. First, I'm going to call the triangle on the left TWP. So we went TWP. Now what I like to do is think of the angle markings. I went from the 1, 3 to 2. So over here, 1, 3, 2 is going to be HDG. Okay, I'm going to go back and give it a new name. Let's go 1, 2, 3 in order that time. So TPW. Over here, 1, 2, 3 is going to be HGD. Third one, let's go PTW. So we went 2, 1, 3. So here, 2, 1, 3, 2, 1, 3 is going to be GHD. Now, there's more we could list. You could find other ones. The key thing we're looking at there is T and H match up. They're always in the same position. P and G always match up to be in the same position. And then W and D always match up to be in the same position. Okay, now we're going to do some solving. So I'm going to match up corresponding parts. So let's start with finding X. So X is W, no it's not, it's VU, right here, VU. So VU is the first two letters, so that matches to TS. So that's going to be 12x minus 7 equals 53. Adding 7 to both sides, 12x equals 60, and x is 5. Now I'm going to solve for y, which is here at RS. RS is the second and third letter, so that matches to VW. So that's going to be 5y minus 33 matches to VW, which is 57. If I go 5y, add 33 over, that gives me 90, so y is 18. Last one for z, that is WU, which is first and last, so that'd be first and last, that's 50. So we're going to say 3z plus 14 equals 50, which is 3z equals 36, so z is 12. Okay, last one. This kind of takes up all the space down here. We're looking at all of these measurements. Now I'm going to do a different approach here. Before going through and finding all the parts, I'm going to just match things up on the kind of left bottom of the screen. So angle C is what I noticed first. Angle C is 103. C is corresponding to Y, so Y is also 103. I have CB is right here. That's 8. That's first and second letter. That matches to ZY, so that is also 8. CM, which is second, third, is YR, so that's 11. And then that leaves me with 15 here. Now, Z is first letter. That is also B, so that's going to be 45. I still need to find that third angle in both of them. Now, I know it's going to be the same, so if I combine those together, I get 148. And that's going to leave me with 32 degrees. That's again from subtracting from 180. So we put 32 there. Matching up everything, now when I go through, I just read the parts that I've labeled. So CM is 11. Realize here we're not naming congruences because it's looking at length, so we use equal sign. BM is 15. YZ is 8. Coming over here, the measure of angle B is going to be 45 degrees. The measure of angle M was 32 degrees. That was the angle we found, which was also the same as the measure of angle R, which is also 32 degrees.